Hello all, my name is Abhishek Bhati, and today we are going to discuss about how we can implement a DBSCAN algorithm. So in order to use the DBSCAN algorithm, we are using a library called sklearn.cluster.dbscan. So let me just go ahead. Yeah, as you can see that we have epsilon value, minimum sample, and this minimum sample actually indicates your minimum points. And there are two types of metric that you can use here. It could be Euclidean distance or Manhattan distance, and it's also up to you and how well it works with the particular data set. As you can know about the data set, let me just show you a very good example that. So I have a data set which is called mall_customer.csv. Okay, now I'll just show the data set. So this particular data set consists a lot of information: customer ID, genre, so it should be gender, age, and we have annual income, then we have spanning score. Now what our aim is should be that I'm going to consider annual income and spanning score. Taking these two features, I'll just apply a DBSCAN algorithm, and based on this density of the points, we'll try to group these particular points together. Okay, so let us go ahead and try to see. So I have done is that I just taken my third and fourth column, which is my annual income and spanning score. I used iLog here, and let me just open a notepad, and these are the steps. For the first step, import the library and dataset. Okay, and this is the unsupervised machine learning, so you don't have any output in this, you just have an independent feature. So finding the similarity of the feature, we are trying to based on the density scan algorithm, we will try to group those features into a cluster. After importing the dataset, we will just I have my independent feature here in my X. Then I'll be just applying my DBSCAN algorithm here. My DBSCAN basically, I have to import the DBSCAN algorithm from the sklearn cluster. I have already written here the second step: import the DBSCAN from sklearn. So my epsilon value is 3, and the epsilon value is that with the help of epsilon value we are creating the boundary and radius of the particular point, and the minimum number of sample is we are considering here is 4, and just execute it. Okay, now our DBSCAN is worked properly. Now the next thing is we have to fit our model. So I written here the third step: fit the model. As soon as I do this, after doing the fit, if I see the model.labels, we automatically get all the labels. You can see that my labels are like this. Now from the labels, that which basically means how many cluster of group I'm getting it. There are a lot of values which will have -1. What this -1 will be, and there are 1, 0, -1, 2, 6, and a lot of numbers. So 0 to 1, I have a lot of this. And this -1 basically indicates that these points are the outliers, and it do not fall in any of the cluster, whereas other points you can see that this is 0, 1, 2, 4. These are my first cluster, 2 cluster, 4 cluster. Now what I'll do is I'll try to find out how many unique groups are there. So for that, first of all, I'll just create a array by using numpy, where I'll consider everything as false. So here everything is false. So what I'll do I'll compare these sample and labels, and wherever these labels values are true, suppose if I have db.core_sample_indices, this basically indicates that on which all index I'm having a different value, which is like a groups apart from the -1. So what I do is I'll take all the indexes and make it as true. This basically indicates that these many from the sample_core, whichever our values are false, remaining all are my groups, different groups. So you can see that all the true values here. Then I'll just calculate the number of clusters. For that, I'll just use the len function of set of labels minus this. My total number of clusters are 9. -1 is the noisy point. The total number of cluster I had from 0 to 8. 0 to 8 is basically my 9 cluster. These are my 9 clusters. Then I can also see my score, which is called as Silahat score, which I used with the steps of my X labels based on the number So this is actually calculated based on the average mean of the number of points that are indicated as noisy, and when compared to the other points that are basically indicated as group cluster. So this is a very good example and algorithm of the DB clusters. Hope you like this video.